Hello and welcome to SciJoy. Today we're going to be talking about motors, which are like robots' muscles.
3, 2, 1, Lego!
So let's talk about what makes up this Lego robot piece. So there's a motor inside that's going to turn your wheels forward and backwards at different speeds, but it doesn't really tell you anything. There's something in here called an encoder, or a motor sensor, and that's going to tell you how fast you're going, what direction the motor's turning in, and how far you're going, and not in like a linear distance. Since a motor is rotating in a circle, it's going to tell you in degrees or rotations how far the motor is going. And that's really useful because your motor is attached to a wheel, and your wheel is also turning in circles. And that's going to travel 360 degrees or one rotation. The circumference of our wheel is 5.5 inches, which is about 14 centimeters. Every time this turns once, your wheel is going to move your robot forward about 5.5 inches. So what if you want to go more than 5.5 inches? That's totally fine. You just have to put in more than one rotation, more than 360 degrees. Rotations are usually used for longer distances. You can break them up into fractions like half a rotation, a quarter of one, 0.7 of one. That's totally fine. But if you're going for smaller increments, you can use degrees because it's a nice way to really break it up and really do a precise movement forwards, backwards, left, or right. Now that we know how the motor system works, let's look at how to program it. If you have watched our previous video and downloaded the software, you can open up a new project. Go down to the bottom, you're going to see a green tab labeled Actions. Click on the Move Tank block, drag it up next to the play button, and it will snap in place. And in the upper right hand corner, you're going to see B plus C. This is the default ports that are always going to be on that block. You don't have to change it. It's just saying that your left and right motors are plugged into the B and C ports. The left one is in the B port and the right one is in the C port. Now if you go down to the little circle with a hashtag symbol in it, click on it, you're going to see a bunch of options. You can turn your motor off, on for a number of seconds, on for a number of degrees, or on for a number of rotations. And right next to that block, you're going to see a left power button. You can click on it and toggle the slider up to 100% or down to negative 100%. And this is going to be power that you can pick for your left motor. And if you know a particular number you want, you don't have to actually move the slider up and down. You can just type it in. Right next to that is your power for your right motor. It's the same thing. You can slide it up and down or type in a number. And the last option is a check or an X. That's going to be braking your motor really fast or allowing it to coast to a stop. So let's go on a little road trip with a robot. We're going to put 50% power in both the left and right motor. Anytime you put an equal positive value in both the left and right motor, your robot's going to move forward. And let's move forward for one rotation, which, like we said, is about 5.5 inches. And just like you in a car, it's going to start at a standstill. And then it's going to ramp up its speed. And when it hits its speed limit, which we set for it at 50%, it's just going to cruise along. And when it's cruising, the program is going to be asking that encoder a bunch of questions. It's going to say, are we there yet? Are we there yet? And the encoder is going to say, we're at about a quarter of a turn. We're about half a turn. And as soon as the program asks the encoder and the encoder says, we've hit one rotation or maybe just asked it and it just passed one rotation, it's going to slam on the brakes and it's going to stop your robot. If the robot is plugged in while it's moving, you can look at something called port view, and it's going to tell you what each of the sensors are doing. We're going to look at the motor sensors in port B and C, and you can look at their power, the degrees they've moved, or the rotations they've done. And if you look at the port view values for the road trip we just went on, you can see the ramp up and the leveling off and the braking, and you can see we went a little bit more than one rotation. So your program's always going to try and drive your motors to get to the exact values that you have set. If you look at changing the power levels and keeping the rotation at 1, you can see the slower we move with the power levels, the closer we are to one rotation. And that's because it has more time to ask, are we there yet? Are we there yet? Are we there yet? And have the robot brake. As you can see, changing the power is not really going to change the distance that you go when you're using rotations or degrees. However, changing the power when you're using on for so many seconds is vastly going to change the distance. While power is not the speed at which you're going, it is going to correlate with how fast you're going. It's like changing from 5 miles an hour for a few minutes to 75 miles an hour for a few minutes. You're going to go vastly different distances. So we know how to go forward, so how do we go in reverse? All you have to do is put equal negative numbers on both the left and right. And let's take a look at the difference between braking and coasting. We're going to use -50 power level for both the right and left motor, and we're going to set it for 2 rotations. And if we use the brake and look at the port view, you're going to see that we traveled 2.02 rotations, which is pretty close to what we want. And now if we use coast, which is just going to say, okay, we've hit our 2 rotations and just use whatever momentum you have left until you stop, you can see that we go a little bit further, which is 2.09 rotations. Remember, we're only at half power, so the more power you give it, the more it's going to coast at the end. So now we know how to go forwards and reverse. How do we go left and right? There's 4 different ways that you can turn. The first way you can turn is by giving one motor a higher value and the other motor a little bit lower of a value. And when we look down at port view when this happens, you can see that the left motor is going to go 361 degrees, and we're trying to get it to go 360, while the right motor is only going at 181 degrees. That's because the program is going to be driving the motor that has the greatest absolute power to that number of degrees or rotations that you've set for it. If you want to make a little bit sharper of a turn, you can drop the right motor value down to 0. To make an even sharper turn, you can give the right value a negative number. And this time you can see that both motors turn about 360 degrees. Finally, the last way you can turn is setting the left motor to 0 and the right motor to purely a negative number, and your robot's going to back up a bit. So let's recap what we've done today. If you want to go forward, you give both motors equal positive values. If you want to go in reverse, you give them equal negative values. If you want to go left or right, you just have to do a varying amount of power to each one of them. They can be positive or negative. But remember, if you give the left motor a more positive value, it's going to turn it to the right. And if you give the right motor a more positive value, it's going to turn it to the left. Thank you for watching this episode of SciJoy. If you have any comments or questions, you can leave them down below. We also have a forum on Reddit where we're talking about this robotics course and the different ways we're programming it. And you can also have discussions with us on Twitter, Tumblr, Facebook, or Instagram. Thank you, and remember, keep exploring.